steps, do I have to ask the user repeatedly, or do you just do it like once? Ask him once and then just run the program
I would
again?
just do it once. I do it to make it as easy as possible for you.
Because what I did was, uh, when we decrypt, we have to know the keys, right? The keys that we used.
Uh-huh.
So would it be, so should we use like an array to keep track of all the keys so that when we decrypt, we
Well,
use the keys again to decrypt?
I mean, you could keep track using an array list, but also what you could do is that you could just simply reset your deck. When you decrypt, you could reset your deck and go through the steps again.
Oh yeah, yeah. We can probably create another deck of the same type, right?
Right.
Uh,
Of the same initial order.
yeah, it's same initial order. Yeah, both of them should work, right? And also, do we print the encrypted word just to see if it works?
Yep.
Or
All right. So okay, so let's go ahead and I will share my screen. Let's go ahead and IntelliJ. So I know a lot of people were having trouble with step 3 for so let me go ahead and create new. So I know a lot of people are having trouble. So I'm going to show you what I find the easiest way to manipulate the deck by showing you how to do step 3. Okay. Okay. So let's go ahead and say we've got this private static void step 3. It's going to take in a circular linked list of integer going to be called deck, right? And then let's go ahead and make sure we, even though this is a not working method, even though these are not full of anything, it's going to be fine for us showing how the code works. That's one of the great advantages of object-oriented programming. I can write stuff without the other stuff, without it working yet. Public. So what I'm just going to add one method here, public e get int index, which given an index, return get node index item. So given an index, give me the node at that, give me the item at that, sorry, give me the node at that index, and I'm going to grab the item for it and return it. So just a standard get method. So that's really all I need. So we've got a deck here, and with step 3, that is the triple cut. That is the taking all the things above the first joker and all the things below the second joker and swapping them. Make sense to everybody? What I'm talking about? That ring some bells? All right. So linked lists, the big advantage they have over array lists is that they are so easy to manipulate and cut apart and split apart and recombine. So I can do this in O of n time just by tearing apart the deck and putting it back together. So what I'm going to do is I'm going to create a circular linked list of integer, and it's going to be the called top, which is going to represent all the items above the first joker. In fact, I will go ahead and name it above rather than top because I'll be using top quite a bit. Above, and that will be a new circular linked list, start out empty. So I'm creating a temporary circular linked list here. In fact, I'm going to create 3 of them. Above, middle, and below. Or is it? Yeah, below. So this will hold, and what this will hold is that I'm going to take everything that's above the first joker, okay? Everything above the first joker and move it into the above, and remove it from deck and put it in above. Then I'm going to take the jokers and everything between them and put them in middle. And then I'm going to take everything else and put it in below. So I'm going to split our original deck apart into 3 parts. Everybody following so far?
Yes.
Okay.
Yeah.
So, and this will take 6 while loops to do. That may sound really tough, but it's not once I write the first one. So while deck dot get 0, that takes constant time to check. So while the top of the deck is not equal to 27 and deck dot get 0. It's very important you do an and there, not an or. So while it's neither 27 or 28, while it's neither one of those, okay? So if the top of the deck is 27, right, this will become true. So, well, if this is 27, this will become false, which means that the entire statement will be false, which means that it will no longer run. Same with 28. But if it's 1 is not equal to 27 and 1 is not equal to 28. So so this will work. So while deck dot get 0 and is not equal to 27 and not equal to 28, I'm going to go ahead and say, hey, one second, my brain just froze. So what I'm going to do is I'm going to say I'm going to say above dot add deck dot remove 0. One statement. So while the top thing isn't a joker, remove that top thing and add it to above. This will stop once we hit a joker. Once we hit that joker, I'm going to go ahead and take that joker and add it to the top of the middle portion. So now we've got all the cards that are between those. So again, we repeat, while the deck is not equal to 27, while the top of the deck is not 27 or 28, we're going to take the top, we're going to look at it. If it's not a joker, we're going to take it, and instead of putting it into above, we're going to put it into middle. Once we hit the second joker, we remove that joker and add it to the end of middle. Everybody following so far?
Yes.
Okay. Now, for the final portion, while deck.size or deck.size, or there should be a size method, I think. So in size, so I think I have to add that as well. Public int size. Here we go. All size is greater than 0. While there's still stuff in the deck, remove it and add to below. Everybody follow that? So now at this point, deck will be empty once we get down to there, and we'll take in, and now above holds everything above the top joker. Middle holds everything from joker to joker, and below holds everything that was beneath the joker. Make sense so far? And now we do our other 3 while loops, which is just simply the same as doing this while loop. We just copy this three times and change it up. So for this one, so now what we've got is that we need to recombine. We've got our 3 decks, and now we got to take the top and the bottoms and swap them. So so first we're going to take all the items from below and add them. So while below dot size is greater than 0, deck dot add below dot remove. So this will simply, while there's still stuff in below, remove it, add it to the bottom of the deck. So we're taking each card, adding it to the bottom. So the top cards will end up on top and the bottom cards will end up on the bottom. Okay, now we just do the same thing with middle. And then we do the same thing for top. Or not top, but above. Take everything from above the first joker and add it to the end, which will be after the second joker now. And that is how you do the third step. Does that make sense to everybody? Any questions about it? Or have you all figured this out by now?
No, that makes a lot of sense. Thank you.
So this takes O of n time because each card gets touched twice. Once when we go down, once when we split it up, and once when we add it and once when we put the decks back together. It works because, and it takes O of n time because all those add and remove operations that we're doing, we're adding to the end, which takes constant time. And whenever we add to the end, we're removing it from the beginning. So that takes, and removing from the beginning in a linked list takes constant time. So, and what's great about this is that you can use this strategy for step 1. You can use it for step 2 if you need to. Although I find getting set to be a bit easier. You can use it to especially for step 4. Step 4, right, is look at the bottom card, remove the bottom card, take everything from, take that many cards from the top of the deck and move it to the bottom, then add the bottom card back in. Well, again, just use the add and remove methods to your advantage there. Right? Once you've written this, you can have add and remove do all that heavy lifting. It's a very, very different paradigm than what we've been doing previously. Any questions before I split you up into groups again? The newest homework that I posted, the stack and Q one, which I had somebody demo it today. It looks complicated. It's not really. It'll be due a couple days after the exam. So you've got plenty of time to work on it after the exam. Okay.
Are the stacks and queues going to be included in the exam?
No. No, they are not. I am focusing solely on linked lists for the exam. Because if I had to focus on stacks and queues, I'd have to make new questions. Other questions? Next Wednesday, 1 week from today.
Can you post this recording at your earliest convenience, please?
Sure, I can post it. I can post it tonight. I can post it basically once the class is ended, but I can copy paste this code into the chat.
Okay, I was more so looking for like what you were explaining to go back through that, but thank you.
Mm-hmm. And now it's in the chat. It's quite possible I made a mistake because I haven't tested it, but it's on the lower end of probabilities. Okay. So, anything else? I won't waste too much more of your time, so I'm going to split you up into groups. Okay. So, 1 second here. There should be a new update for Zoom, by the way. Let participants choose room. Let's see. All right, create 8. I'm going to create 8 breakout rooms. Go ahead, See if you can assign yourself to a room. Open all rooms. Okay. Are people able to choose their own breakout rooms?
I don't see
I don't have
anything.
anything like prompted.
Close all rooms. Okay. Recreate. Let participants choose rooms.
Should it work for us if we didn't update to the newest version? Because some of us might not have the newest one.
I have no idea. Open all rooms. So I've opened up the rooms. Go and click breakout rooms and tell me what you've got.
Only the host can see the breakout room
Yeah, I
button.
don't have a.
There is no
breakout
pop-up.
room for that.
Ah, fiddlesticks.
Maybe next time.
Fiddlesticks. Okay. Everybody should update to the latest version of Zoom. So options. Okay. So let's see. Allow participants to choose room. Allow participants to return to main session. Okay. So sign. All right. So just tell me who you want to be with and I'll go ahead and do this. Okay. 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 Austin, Jonathan, Chase. Okay. So open the rooms and now start assigning people to rooms randomly. And by randomly, I mean I'm clicking. It's possible that you end up.
Hey, Professor, I want to see if I could demo this real quick.
Okay. Go ahead. Let me go ahead and enable screen sharing.